Yes. So can I see the chat if someone is writing something? Okay, Sumina is writing yes, Priyanka is writing yes. Okay, good. So we are going to start today. So today we will see the interface of general linear model and generalized linear model. So that's a type of linear modeling. Okay, start नहीं किया था recording. अब हो गया ना. Last time we forgot.
Recording off है.
देख check कर लो एक बार.
The recording is on.
Okay. So today we are going to discuss the linear models. The same various types of regression. Till now you have seen the logistic regression, the multinomial logistic binary logistic regression, multinomial logistic regression, and the ordinal logistic regression. So these interface can be accessed or can be run through the option of mixed model or the linear models, which we will see today. So that option, like on day 3, when we were performing the ordinal regression, many of you asked, like, is there an objective way to check for the assumption of proportional odds? So yes, there is. And I told that it is through the option of linear model. So we will show that today. And again, the few other types of regression, like the Poisson's regression and the conditional logistic regression, that we'll see. And we'll also see the regression. Till now we have not used the term interaction. So if you have to perform a regression with interaction, then how you are going to do that. So that also we'll see. So I'll first show you the interface of this linear model. So if you see, yes, I'm telling. So all of you, if you see that if you type in your this module, if you click and type the linear model, then that will not come. Why? Because the in Jamovi, when we installed Jamovi, I asked you guys to install the solid version. If I go to, let's say, if I go to Google and type Jamovi software download, okay, and click it. When I click this Jamovi desktop, two option comes. 2.3.28 solid version that we all have installed in our laptop. But for linear models, this module of linear model is not available in this solid version. This is not there. So if you type plus and if you try to install the module, it will not come. So it is present in this current version. Okay. So this current version you need to install. So that you can do in the breakout room, and all the mentor is requested from you that you please help them to download this current version. So you just have to go and click, and it will ask to and just give a command of run as an administrator. Since I have already downloaded it, so it is there in my laptop. And when you open this, so ideally, how do we open the Jamovi? You go click this option and type Jamovi here. Jamovi. So in my case, can you see like there are two options? One option is this. This is the version which is there in most of us. And this is the newer one which I have installed, that current one. But the download happens with two types of interface in all of your laptop. So many of you will see that there are two types, like Jamovi 2.6.19 and this Jamovi 2.6.19 debug. Can you see there is a term debug? Okay. So, like what we have experienced that in my laptop, if I click directly this 2.6.19, that gets opened. But in Dr. Shamshad's laptop, he has to open with this option of debug. So I don't know, you have to check with your system. There are some specification, but it gets both these files gets downloaded and you need to open this. Just check what is opening in your laptop or your system. First is this. The second is a very important, if you have already opened this version 2.3.28, then this will not get opened. So you close all your previous Jamovi files which you are working and then open this and import the file once again. It will not be like whatever file you have imported in 2.3.28, you just close this and import the same Excel file in this 2.6.19. Then this option, because all the features of this linear models, that is there in the current version. Okay. Am I making myself clear to all of you? Have you understood, all of you? Don't panic if you don't see this in 2.3.28, because solid version has not this option of generalized linear model or linear model. That option is there in the current version. We have asked you people to download the solid version because that's recommended for most of the user, and basic functions we can do that. Maybe after 3-4 months this option will come into the solid also, because how it works, generally they test these modules in the current version, and then once it gets stabilized, then they shift these modules to the solid version. So probably after 3-4 months this option will be available in the solid version also, but currently it is there in solid version. You don't have the all the features of the this linear models. Is it okay? Can someone write yes or no, so that I don't know whether I'm making sense to you people or not? Can you recall when you were downloading the... Okay, Dr. Sumana is saying yes, Priyanka is saying yes. Okay, thank you. So that was regarding, so file which I have this, you can just check. How will you check your version? So you can see there is a 3 dot here, this one. Okay, you click this and go, and you can see then 2.6.19. How you have to check your version? Click these 3 dots and then you can see this is my version. Currently, I am working on the current version, not the solid version. Okay, version 2.6.19. Is it visible to all of you? Anuradha is saying that she is using. That's good. That's good. Okay. If you have been using that, that's pretty okay. Then that option will be there. So how you will do that? You go to plus and then go to Jamovi library, and then if you type like generalized or you type linear models. Okay. Something it is writing, but if you type like... This is the name, General Analysis of Linear Model. I'll just show. Probably there is some error is showing. GAML J3. Can you see this? This is the option of the general analysis for linear model. Should I close? I'll close this and once again open. Don't save. If I open this. Go to Jamovi library. I don't know why it is showing. Maybe you can just check if the same is showing to you. Can you check? Is this the same case with your this thing also? Okay, so maybe some issue with the this Jamovi or with my system, or I don't know. Sometimes Jamovi behaves like this. So maybe Dr. Shamshad is also checking at his laptop. Probably, let's see. So you need to download this. The main is like, if you see, you need to download this GAMLJ3, this one, General Analysis for Linear Model. This you have to download. And then this is the interface. So this is the interface of linear model. It appears like this here, linear model. And then I'll show, if you just,
सब जगह
तुम्हारा भी, yeah.
इशू होगा
Maybe if you have downloaded, that's why.
नहीं जामोवी का इशू है
Okay, maybe some issue with the Jamovi, because Dr. Shamshad is saying that it is there in his laptop as well. So probably, if you are not able to download it today, those of you who have already downloaded the current version, you can share your screen and you can like,
क्लाउड का हो सकता है
okay, yes. You can do it on cloud also. Dr. Aditya Rudresh is saying that the module can be installed on cloud version. Okay. So these are the options. If you see this linear model, there are 4 options in this linear model. There is a general linear model. There is a general mixed model. There is a generalized linear model. And there is a generalized mixed model. So if you see these names are very confusing. Like if you don't just see it carefully, you will get confused. What is the difference between this general linear and generalized linear? Okay. So basically this general linear model, if you see this first one, this is basically for the linear regression. So general linear is for the linear regression. And because all regression, the basic origin point is the linear regression. So the logistic regression or probit or Poisson's, it all comes under this generalized linear model. So we will see these 2 options, general linear model and generalized linear model. Whenever this term mixed comes, like general mixed model and generalized mixed model, that means it has got a specific options of like stratification. So whenever you do the repeated measure analysis or you do a cluster level analysis, then this option of linear mixed model you should use. But we are not covering these 2. Why? Because this is not related to our workshop. So we are only covering the general linear model and the generalized linear model. So if you click this, let's say I open this general linear model first. So those of you who have performed linear regression at some point of time, here you can see it is the dependent variable. Dependent variable is the type of continuous variable in case of a linear regression. These are the factors. If you see the sign, this is nominal, and the covariates we increase like scale variable and the ordinal. And then you can see the effect size, the eta square, partial eta square. The estimate is there with the confidence interval. Beta of confidence interval is also there. And then these are the model parameters. So you can include these model parameters here. And then there are other options like plots and assumption check. So these are the plots. And then there's assumption check, like we check for the residual, the normality, and then homogeneity and collinearity. So a lot of assumption check here in the linear. So I'm not discussing all these because we will see few options in case of a logistic regression and the Poisson's and ordinal regression. Since we are not covering linear regression, but still those of you who have at least done it on SPSS or on Jamovi, you know a little basic of that. So linear regression is through this general linear model. General linear means only linear regression when the dependent variable is continuous in nature. Coming to the other option, which is the generalized linear model. If you click this generalized linear model, then you can see the option here. So you can see here you can do a linear regression also, or you can do the regression of categorical dependent variable. Now, categorical dependent variable, you can do this logistic regression, you can do this ordinal logistic regression, and you can do the multinomial. So all these three you can do go either through the regression. We have used this option. But if you want to perform higher analysis, higher means it has got few more options. Like in case of proportional odds, that simple regression option that doesn't have the test of parallel lines, which I was saying you guys on Saturday, that we'll see this option on Monday. How to check it for objectively when you don't have to create four separate dummy variable and you can test it only with a single click, because that option is available here. And again, you are having one more many other options also, like higher level of modeling. So this may not be needed for most of you. Why? Because as one doctor was saying that day, she's from microbiology, or even if she's not from microbiology, for other people also who wants to keep their analysis simple, you can go with this option of regression. But since we thought that the test of parallel line was not there in case of ordinal logistic, and if you wish to do the ordinal logistic, then you should be a little familiar with this option of linear modeling or generalized linear modeling also, right? So other we will see when we will perform. And then there are this thing of frequencies also. If you wish to perform regression analysis on frequency means count. So you can go for this Poisson's regression also. Poisson's regression is a type of regression when the dependent variable is a count, like number of newborn in a hospital or number of diarrhea episodes. This will be a discrete count. It cannot be in fraction. So again, you can perform a linear regression also, but we will see why we should not perform a linear regression on counts, right? So Poisson's regression can be performed in case of a dependent variable if the dependent variable is uh, counts, right? Yes, Dr. Arun, you have raised your hand.
Good afternoon, ma'am.
Good afternoon.
Ma'am, in the generalized linear model, what I see on my screen is that the under categorical dependent variables, uh, there are all the regression models that we studied. For example, we studied binary logistic, we studied ordinal, and we studied multinomial as well. So, ma'am, that means that once we do our inferential, when we build a model, so can we directly do all those under this generalized linear model, or do we have to do separately as you had taught
No, no,
previously?
no, 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 no. It depends. See, everyone is not at the same level, right? Many of you are already doing a lot of analysis, as rightly said in the introduction session. Many of you have been working over SPSS or many other software. Okay, so you people are very well versed with most of the functions. So for those who are very comfortable doing it like a very basic level, you can go ahead with this. Okay, with this generalized linear model. But for beginners or to keep it simple, because see, the interface of this generalized linear model is a little complex. Complex means it has got many other functions, which to use those functions, you should be very much confident in those concepts and whether you should use them or not. So that's why, if you ask from me, so if you are doing it, like if you've not done it many times and not very familiar, then you should go with the regression, this option, this option. Okay. GLM is basically, it is for basic and advanced. So if a person is belonging from a statistical background, basically, they don't go by this regression. Generally, we as a medical profession, we use these things. They use these like generalized linear model, or if you see the literature, generally this option they use. So you can ultimately, if you see the value of odds ratio and beta, that will come same, like table and assumptions. But if you want to perform the higher level analysis, which we are not covering, like if you want to see, there is something known as the simple effect and there is something known as the, uh, you know, main effect. So all those things, random and fixed error, those concepts we are not going, because I think that is not needed. That's at this level probably. We may keep a separate session where only those people will be there who are well versed with the very basics. They are very confident, and then we can build those concepts. So Dr. Arun, probably if you like you have been doing this for, I guess you very well know all these concepts. So yes, you can try. So it's very individual actually approach. So you can see it actually. I'm not asking. Rather, I'm not saying anyone not to use or to use. We are demonstrating. If you find this more useful, you can use this. If you find the simple regression option more useful, you can do that. Right?
Yeah.
Am I making myself clear, Dr. Arun?
Yes, ma'am. Yes, ma'am.
But for most of you, if you don't wish to go through this, right, linear model, then at least for test of parallel line, you can use this option. Okay, because that option is not there in the proportional odds. And checking the proportional odds by creating 4 dummy variables, and that is also very subjective, because odds is like if it is differing by, let's say, 0.1 unit or 0.2 unit. So will you call it as a proportional, or you will call it what? So that is a little subjective. That's why if you want to keep it objective, you can use this option. So what we recommend, you use that option of regression. For test of parallel line assumption, you can use this. Again, I think one participant was asking regarding the post hoc comparison. I probably, Sushmita, I don't remember the name, on day 2 or day 2 probably. So if you wish to do that post hoc comparison, so it depends on your paper actually, what research question you have and what type of analysis you want to make. Then yes, those options are there. You can explore further also. Okay, so that you can do. So we'll see though that test of parallel line which we learned on Saturday, the proportional odds, or this one, the ordinal logistic regression, we can use that. But again, interface, like if I click this logistic, you will see here that options are like same. There is a dependent variable, there is a factor, there is a covariate. If you come down, it has got few more effects. Okay. And again, you can see here that here, in case of a law, if you go through that, you will only get odds ratio. But here you will get relative risk also. Like if it is a follow-up study, there you don't get this option of relative risk. Here you will get a relative risk. Again, that model is same in that this thing, there is something known as the covariate scaling that you can do if you have not selected those variables. So I'm not telling you these concepts. Okay. Why I'm not telling? But because that's not the objective. I just wanted to introduce this generalized linear model. Why? Because I wanted to show you the test of parallel line. But for that also, I need this, because see, if you click this ordinal proportional odds, I'll show you over the data also. And if you go down and if you see the option, you can see there is an option of parallel line tests. This parallel line test is for the testing the assumption of proportional odds. And this, you can check it objectively over here in the linear models. So if you have seen this, I'll cover a little bit of the interaction. So we have told in the binary logistic, we have told you the concept of subgroup analysis. If you can remember, how do you perform subgroup? You use the option of filter, and then you perform all those analysis only on the selected cases, like selectively male or female, or selectively on emergency surgery versus planned surgery. So any specific group, if you want to see if I take the same example of cancellation of surgery, then you can perform your analysis. So this is the same interface which you are seeing here, general linear model. It has got the option of general linear model, general mixed model. So wherever this term mixed comes, that means it is something like a cluster where you that particular this thing is nested within the other. Cluster level analysis if you have to perform, or if your analysis is of repeated measure, then also you can do this. So now I'll show one example of this interaction. Okay, so I'm starting with the interaction in linear regression.
ஒண்ணும் இல்ல அப்புறம் கண்ணன் தண்ணி வருது
What do we mean by interaction? So we'll see because we did not talk about it interaction. In the variables, we have only, do you have any idea regarding interaction? What do we understand with this interaction? Yes or no? Then, like, can I see the chat box? Have you ever heard of this term interaction?
Ma'am, it is something like, ma'am, can I speak?
Yeah, please. Please go ahead.
Ma'am, when we are building a model and there are multiple predictors, so one predictor could have an effect on the other predictor,
Very
and
right.
because of which the effect on the dependent variable, because of the predictor that is being affected upon, will be affected, and because of and so this is a process to find out quantitatively whether there's such a relationship exists or not.
Okay, very right. Rightly said, Dr. Arun. Generally, what happens that whenever you see that beta or odds ratio, that gives you the effect on the dependent variable, keeping the other variables constant, right? That's what we said. Like if you increase this, or there's a twofold risk of cancellation as compared to the regional anesthesia or whatever you say, the other predictor variable you keep constant. That's what we always say, keeping the other predictor variable constant. But in case of an interaction, uh, you don't assume this, and then you see, like, if two, we'll express this with example. What do we mean by this? So suppose my research question is, like, does the level of physical activity, I have classified physical activity in low, moderate, and high, and dietary habit. So dietary habit, again, I have classified with the vegetarian and non-vegetarian. And my dependent variable here is the BMI. So BMI is a which type of variable? If I have not classified BMI as a like obese or overweight or normal or lean. If I'm not classifying it and I'm taking the value of BMI, which kind of variable it is? Is it a continuous variable, or is it a categorical, nominal? Which type of variable this is?
Continuous.
Yes. So Dr. Ganesh has rightly said it is continuous. So if the dependent variable is continuous, we'll go for the linear regression. So, and the two variable which I'm seeing, like, is it only the BMI, or is it only the exercise? Like if I'm only exercising very high, but I'm going for a non-vegetarian diet, or I'm going for a vegetarian diet. So does the level of physical activity and dietary habit influence BMI? So if my research question is this, then of course my dependent variable will be BMI, independent variable will be these. And interaction means we'll see that if I am not keeping the other variable constant, and if I want to see whether the physical activity, does the dietary habit also affect the physical activity and the BMI. Okay. So this is the data set. I will show you on the data set itself. I think let's open that. Okay, so I'll open the Jamovie. So this is the data set. Let's see. It has got these many variables. Participants are there, then the gender of the participants, age of the participant, the physical activity level. And if you see its physical activity, I have classified it as low, moderate, and high. And if you see the dietary habit, again, you can see here, I have classified dietary habits at non-veg and veg. And if you see this BMI is a continuous. So this is these are my variables, and this is my data set. Coming to the data, if you see the data again, this is the same. So now I have to, I am just showing you the interaction. So how I will go? I will click. If you see interaction, it can be done over the simple this thing also. If you don't go by generalized linear model, and I will go with the plain this thing, regression. So let's say even if I open this linear regression, I'm right now not going with the generalized. In the linear, in this here, I will enter the dependent variable, which is the BMI. In the covariate, I will enter the age of the person. And in the gender and physical activity, I will enter as a and dietary habits. So all these three I have entered here. So this if you see the odds ratio here, let me click the model coefficient. I will go for the, sorry, in this case we don't have odds. I have the standardized estimate. Okay, because there's no need to here, whatever is the estimate, this estimate, that is the direct one. We are not using logit function. That's why you don't need to convert it into the odds ratio. So these are the estimate, and you know that how it gets interpreted, we'll see that. So how do we interpret in case of a linear regression? So we say that, like, let's say we are seeing the gender. So this is the value 1.14. So BMI is a dependent variable and the reference level is female. So what I'll say that, or let's say if I am talking about exercise and the dietary habits. So if it is 0.98, that means if 1 unit in if I see the value of this BMI has this 0.98 higher, lower BMI in case of a person who is doing a moderate exercise as compared to the person who is doing a low level of exercise. Similarly, high, we will see that it has got 0.18 BMI less in case of a person who is doing the high level of physical activity, taking the reference as a low level of exercise. And if I am seeing the dietary habits, what I will say that a person who is a vegetarian is having a 3.23 unit of BMI less than the person who is a non-vegetarian. So this, all of you, this is almost same the way we have done for the logistic. The only difference is in logistic, we use the odds ratio. Why? We know the theory now because we have to fulfill the assumption of linearity. We used that logit function where we converted the 0, 1 into the probability and that probability into the odds, and then we took the log of that odds, and then we have performed this. That's why to again convert that back into the odds ratio, we need to take that exponent, because then only it will be converted into the odds ratio, right? But here in case of a linear regression, we don't need to do that. So this is the example of when I'm not seeing any interaction. Now, if I think and if I'm interested whether this effect of physical activity gets changed with the if I use this dietary habit also. So how will I go about it? You can go into the model builder, and here that day we did not discuss about this term. There was an interaction term. So you can add a new block, and then you can you can enter these dietary and physical activity together in this new block, and this is the interaction. If you click, it is not going here. Okay, I'll drag it here. So it has gone here, and you can see that the star appears here. This one. This means that there is an interaction. So it will take some time. And now if you see the result, so it will give you the interaction. So this is the beta. Now, if you see the p-value, so p-value of this interaction, the upper one, this one, it is not significant. If you see the p, so these are the p-value of this is the interaction term, and interaction between moderate and veg and non-veg, it is, so this is t value, sorry, this is p value, this is not significant. but interaction with this and this, it is significant. This one, right? So how to interpret this? So you can say that in people who are doing a high exercise, if the person is vegetarian, there is a additional that there is a decrease of 3.28 unit. That means there is a difference between the BMI between veg and non-veg by 3.8 units as compared to the person who is doing a low exercise. So this is the interpretation if you use this interaction term here. So interaction means if I think that there is some level of intermingling, or there is some level of effect of dietary habit over the physical activity, together they are affecting the BMI. So I may use this term interaction in my model, and you will see in many people they don't use this interaction actually. But again, you will find different levels of manuscript, and many people they use also. So it is up to your research question whether you want to use it or not. So again, and in this case, I'm just explaining what do we mean by main effect. So main effect means, does the physical activity level significantly affect BMI? Like we have seen. In that case, the dietary habit and other we'll keep constant. The main effect of what will be the main effect of dietary this thing? The main effect of dietary habit will be the how it is affecting the how this dietary habit is affecting the BMI. And if what do I mean by interaction term? That interaction terms means that the does this effect of physical activity on BMI, is it dependent on dietary habit or not? So Anuradha is asking how to describe this interaction. So this interaction describe means if you have seen in the literature that this interaction is there, or maybe if you think you can check it. Actually, statistically, you can always put this and see whether it is significant or not. And if it is significant, you can report it. If it is not, then also you can report it that it was not significant. And definitely you can write in your result if you think. So this is one way of checking for whether, but for that you need to justify why you are looking for that. Have you seen like is it one variable is confounding the other variable or effect of, so I'm not going into the detail of like identifying those confounders and moderating variable, because you know what a confounder is. So if the effect of that effect or whatever odds ratio it is coming, if it is getting modified by the presence of another, uh, then you can definitely go for such interactions. And this you should have some valid reason to say that why you are performing this interaction, right? So that's the main purpose of showing the interaction. Just for statistical this thing without having a biological plausibility, you should not perform an interaction. So yes, Dr. Arun has raised his hand. Dr. Arun, may I know your question?
Yes, ma'am. Ma'am, the results that we were interpreting when we did the interaction test for physical activity and diet, in which the physical activity was subdivided into high and moderate, or I think moderate or low, and veg and non-veg. And the result of the beta or the coefficient was minus 3.28. So, as I understood, uh, the ones who are on high physical activity and are consuming a vegetarian diet have 3.28 time odds less than the ones who are
It's not
having.
odds. First, it's not odds. It is linear regression. So odds, yes, we will talk
Sorry,
about
yes,
odds in ordinal in logistic
so,
regression, but
sorry,
3.2
sorry.
unit less. That's okay. You are right. Again, you can repeat it?
So, ma'am, the physical activity was uh, subdivided into two parts, the high
Mm-hmm.
and moderate, and the
Mm-hmm.
dietary was also into veg and non-veg. And
Mm-hmm.
the result of the coefficient was minus 3.28.
Mm-hmm.
So the correct interpretation was that in for physical activity, the reference was taken as moderate, and for veg, for diet, it was I think taken as non-veg.
Yes, you are
Yes,
right.
ma'am.
So you will
Yes, ma'am.
rotate both these up level. Like in person, who is doing high exercise, taking vegetarian food, is having 3.28 less BMI than person who is doing the low activity and are non-veg. Okay, you are right.
Ma'am, uh, if we want to take the interaction of a continuous variable with a categorical ordinal variable, then also, ma'am, it can be done.
Generally, with the continuous variable, you don't do we perform, you put it as a covariate. Uh, Most probably you will see that in case of a logistic also, we can perform, but what it does actually, for continuous variable also, it classifies that continuous variable into categorical. We'll see that it checks it divides it into three this thing. One value is mean minus 1 SD, the other is mean, and the third is mean plus 1 SD. I'll just show. I think we have one.
पेज से कर सकते हैं.
Okay, let's do it. No, this was not the one, na? This I will go with. But for that, you need to see the. If
Yeah,
I.
देखते हैं. मैं try नहीं किया.
Yes, I have not tried, but let's see if you have said age and what age and physical activity, right? What
Yes, ma'am. Yes, ma'am. Yes, ma'am.
age,
Because it is a continuous variable, no?
yes, age and physical activity. Age and physical activity. Yes, you can see age and physical activity. So both of them are not significant, but if they are significant, then how will you say? So it's actually first we have took the age. So if I see the how will the interpretation be? A person, I think age. No, I have moderate and low with increasing age. If I put this, see, I can. Let me put it back. I'll tell you. If I put age later and this thing first, then also age. Let's first put only the two category thing. This. I've just taken this dietary habit, but this is also not significant. So I can say here again, I'll take a person who is having my dependent variable is BMI. So with increase in at every year additional this thing increase in 1 year, a person who is a vegetarian is having a 0.04 unit increase in the BMI. That will be the interpretation. So you have to see the first variable. How we do? See the first variable and think it independently as if the second is not there. So how I write that with every year increase, the BMI will increase by this thing. But again, I have to add this also. With every year increase in age, a person who is a vegetarian, he has got a 0.04 unit BMI more than the non-veg. And if you see age independently, it is 0.06. Like if you see independently, if you see the upper one, this one, although this is not significant, but just imagine if it is not significant, you will just write that it was not significant. But if it is significant and if you see the difference, it is 0.04 here. Okay. If we don't take the dietary habit into account, with each addition year of increase in age causes the BMI increase of 0.06 unit. Okay. But if you take the vegetarian, then this effect is like increases 0.04. That means that there is a decrease in BMI of 0.02. If the person is on vegetarian diet, as compared to a person who is a non-vegetarian diet. Am I making sense to all
Yes,
of you?
yes, ma'am. Yes, ma'am. Ma'am, okay, ma'am.
Yes?
Ma'am,
Yes.
ma'am, one of the assumptions before we attempt a linear regression is we check for multicollinearity, ma'am.
Yes.
So, ma'am, multicollinearity in a way just tests also whether one predictor variable is affecting the other predictor variable. If we have satisfied that thing, ma'am, then why should we then go for again for interaction, ma'am? ये मुझे
No,
समझ नहीं आया.
actually, see, all those multicollinearity and all, they are statistical, this thing. Yeah, statistically it is testing, no doubt. But still, that multicollinearity, in that you say that you have, these two are different thing. By the interaction, that doesn't mean that they are highly correlated with each other. The effect of one variable is acting as a probably the moderator variable, you can say. I'm not classifying the various types of variable, but it might act, you can say here that the vegetarian is acting as a confounder probably, because if you see its independent effect, it's 0.06. So those two things are not same. Don't confuse, like if it is multicollinearity, that means there will be interaction. Are you thinking that way? Like if you are thinking that if there is a multicollinearity, interaction will happen or will not happen. What do you say? You, according to you, since
Ma'am,
we have removed, it should not happen. That's why?
yes, ma'am. Yes, ma'am.
No. It's entirely different. See, interaction, it's in the biological world. Multicollinearity means you, that particular variable is somehow derived, or biologically it'll, like if one is increasing, the other is of course increasing. That is multicollinearity, means highly correlated with each other. Why we remove? Because then you cannot see that the effect on the dependent variable, whether it is due to the variable A or variable B, because both are highly correlated. But in case of this interaction, you are checking whether the effect on the dependent variable is getting modified or altered. Otherwise, in case you can take both highly correlated variable. In that case, interaction will not show any. In fact, it will always become non-significant because they are highly correlated.
मैम,
Okay.
मैम, बात तो एक जैसी लग रही है मैम सुनने में.
नहीं, एक जैसी नहीं है. कोरिलेशन और इंटरैक्शन, ये दोनों डिफरेंट होता है. और आप इसको एक बार फिर से रेफर करें. अभी उस पे हम अभी नहीं जा रहे हैं, लेकिन
जी मैम.
ऐसा बिल्कुल भी नहीं है. लीनियर, इनफैक्ट इंटरैक्शन देखने के लिए भी कोलिनियरिटी इंपॉर्टेंट है, बिकॉज इंटरैक्शन इज वन ऑप्शन ऑफ लीनियर रिग्रेशन. सो दैट कोलिनियरिटी अजम्पशन, तो आपको तो वो वेरिएबल हटाना ही पड़ेगा. आप हाईली को रिलेटेड वेरिएबल में इंटरैक्शन देख ही नहीं सकते हैं. दैट शुड नॉट बी डन. You are contradicting your own point. What I am saying, that if there is a collinearity, you cannot check for interaction. Are you getting my point?
Yes,
You
ma'am.
can
Yes.
check for interaction only if there is no collinearity.
Okay.
Right? That's because linear regression के assumption में यहाँ पे जब भी आप ये perform करेंगे, आपका जो यहाँ पे इधर इसमें नहीं है आपका assumption check. If I go to the assumption check, yes, this collinearity statistics, if I click that, and if you see the value of VIF, here you can see all. If अगर यहाँ पे किसी भी वेरिएबल का वैल्यू 10 से ज्यादा आता, उसका आप चेक ही नहीं कर सकते इंटरैक्शन. आर यू गेटिंग माई पॉइंट?
क्योंकि मैम लेस देन 10 दिखा रहा है कि ये आपस में कोरिलेटेड नहीं है. एज का जेंडर से कोई नहीं है, जेंडर का एज का फिजिकल से कुछ नहीं है, एज का डाइटरी से कुछ नहीं है, एज का इंटरेक्शन से भी कुछ नहीं है, वाइस वर्सा आल्सो.
यस. इज इट ओके?
यस मैम. तो क्योंकि ये कोरिलेटेड नहीं है, इसलिए हम इनका इंटरेक्शन भी चेक नहीं करते.
इंटरैक्शन चेक कर सकते हैं, उल्टा
कर सकते
कर
हैं.
सकते हैं. अगर कोरिलेटेड होते तो हमको उसमें अपने मॉडल में से ही हटाना पड़ता उसको. Yes, like Dr. SV is writing, we will have to remove that variable from our model. आप जो भी वेरिएबल का अगर आ रहा है VIF 10 से ज्यादा, आप उसको मॉडल में ही नहीं रख सकते हैं, आपको हटाना ही पड़ेगा उसको। तो आप इंटरैक्शन कैसे चेक करेंगे?
जी मैम।
ठीक है।
ओके मैम।
So other people, have you understood regarding the concept of this? I am explaining it in linear regression. We'll come to logistic also. ये आपको समझ आ गया? Everyone, can someone write? Priyanka is writing yes. Okay. Only, चलो प्रियंका अगर समझ गई तो बाकी भी समझ गए होंगे।
Excuse me, ma'am.
Yes, Dr.
All,
Anuradha.
all the assumption checks, like in this linear GLM, what are all the assumption checks? We have got a lot of selections here, a lot of options here. So
I have not gone to अभी तो we have not gone to the GLM. Right now I'm using this regression option only.
okay.
This is linear regression. I have not told these all to you people. Okay, so don't, I mean, we have our videos on linear regression also. You can see those videos if you wish. And there we have explained all these assumption check. But this whole 5-day workshop was on logistic regression, multinomial, and ordinal. And we'll cover today the conditional logistic and Poisson's also, and ROC. So in these
Okay.
5 days, we have not covered. That's why probably these may appear new to you. This is not, I have not still opened the GLM. It is through this option of regression only. Okay, I'm not opening. Why? Because for us, most of the options are here except for parallel lines, I said. I wanted to tell you that. That's why I have told you. So have you understood up till this point? Anuradha, are you clear?
Yes, ma'am. Yes, ma'am.
Okay, okay. Thank you. So now we'll see the other. Let's see this in. So I was telling you this. So here it was a covariate. So this was again the same thing, physical activity. So if you see the p-value here, it was not significant. This is again the same output of Jamovi, not the same with the physical activity and dietary habit. Both was not significant. So how do we interpret the main effect? So in this case, what is the intercept basically? So intercept is something, you can see here the value of intercept is 25.46. What do I mean by that? So Dr. Arun also asked like, what do we mean by intercept? So in case of a linear regression, you can definitely convey this, that this is the estimated BMI when all the predictors, that's what we said, that they are at the reference level. That means low physical activity, non-vegetarian, female, and age 0. Whereas age 0, it is never there because biologically it is not possible of age 0. Something will be there like in weeks or days or hours or minutes. But it is a hypothetical situation when all the predictor variable is 0. And especially in case of a continuous. Yes, for categorical, you can have a 0. Why? Because all reference, we take it as 0. So it is basically, it is the overall mean BMI. If you calculate, if you go to descriptive and calculate BMI, it will come like 25.46. Coming to the other, this thing, the age. So how do we interpret this? We have seen that for each additional year of increase, the BMI increases by 0.06 unit, assuming other predictors remain constant. If you see the physical activity, you have got two levels here. So if you compare the first one, moderate versus low, if I compare this first one, so what will I say? That the coefficient value is 1.11. So it is physical activity. The person who is doing the moderate physical activity is having a 1.11 unit less BMI than those who are having a low physical activity. Similarly, if you see this high versus low, which is significant, this one is not significant, this is not significant, but this is significant. So I can say that the person who is doing a high physical activity is having a BMI of 1.82 unit lower than person who is doing a low physical activity. So coming to the interpretation of gender. So gender again, male, if you see reference is female. So male is having 1.62 unit BMI lower than those of female, and it is significant. If you see the dietary habit of vegetarian, it is the BMI in vegetarian is 1.77 unit lower than that of non-vegetarian, which is significant, right? Now, if you see the interaction, so interaction term is like, does the level of physical activity on BMI depend on the dietary habit? Like, is the effect of physical activity on BMI is getting modified or changed by the dietary habit or not? So, you have got two interactions here, moderate and low, and this high, low, and veg, non-veg. So, again, like I said, you take the first. How do we interpret this? So first see the first two levels, moderate and veg. So how will you say that? You will say that the person who is doing the moderate exercise, the difference between the veg and non-veg, the difference in BMI between non-veg and veg is 1.39. That means a person who is doing a moderate exercise and taking a vegetarian diet is having 1.3 units higher BMI than the person who is doing the low exercise and is taking the non-veg. But again, it is not significant. The other one is also not significant. So that's why when it is not significant, you will not, interpret it. You will just say that it was not significant. So whenever there is a significant interaction, you will see that lines which you will draw. This is a graph. Will show you the option. It will not cross. Like it will not cross means both line will not cross. And if there is an interaction, they will cross each other. Right. So this is the interaction. This is again the same thing. If interaction is present, like this we have just seen. The estimate was 3.28. So how I will say, the person who is doing a high level of physical activity and taking a vegetarian diet is having a 3.28 unit less BMI than the person who is doing a low exercise and is non-vegetarian. Am I making sense to all of you? You take the first one. How to do that? You see this value and take the first this thing. Sorry. High and veg. And then reference will be low and non-veg. So same I have written here also. This is the same write-up and this is the graph. So if you compare both the graph, you can just see the distance here is less and distance here is more. Why? Because the differences here is significant. So the difference in BMI was more here and it was less here. Now coming to our example of surgery cancellation. So if I wish to see the interaction between type of anesthesia and type of surgery on the likelihood of surgery cancellation, if I want to see the interaction between these two, how will I see? So I'll go to the data type. Surgery cancellation. So I'll go to the regression, binomial. We have performed this. Surgery status in the dependent variable and in the covariate, age, BMI was not significant, chronic disease was also not significant, admission type, anesthesia type, and surgery type. If I am taking only these three, and then I'll go to the model builder. And here in block 2, I may add a new block. And this thing is interaction between surgery type and anesthesia type. So I will select these two and I'll shift these two here in the interaction, this thing. So now if you see, if you see here, you have to, in the model coefficient, you have to click on the odds ratio, because for interpretation, we need the exponent of this estimate. So if you see the, first you see the p-value. So p-value is not significant. So if p-value is not significant, I will not comment and I'll stop. I'll write that the interaction between the anesthesia type and surgery type was not significant. But if it was significant, then how I will interpret this 1.37? So what I'll say again, I will take these first two level, regional and planned. So I will say that the odds of what Dr. Arun was saying initially. So the odds of surgery cancellation in regional anesthesia and in planned surgery was 1.37 times more than the general surgery and the general anesthesia and emergency surgeries. Okay. Or you can write as compared to the reference level simply. So this is the interpretation of interaction in case of logistic. In logistic, we always talk in terms of odds. And in linear, we talk of like increase or decrease in the dependent variable. Why? Because that is the in the continuous variable. So that's how we interpret the interaction. But for that, before commenting, you should see the p-value. If it is not significant, then you will just not say anything. You will only say that interaction was not there. So this was like here you can see the same. This thing is there. P-value was not significant, so there's no need to comment. And if it is again p-value was not significant. With interaction, like if the p-value is significant, here you can see, then you have to comment. And then you will see that these are coming like very near to each other. At some point of time, they will cross each other. So if the interaction is there, these things you can see in your graph. And how I will say, I will again say that there is a significant interaction between the anesthesia type and surgery type. Means that the impact of anesthesia type on the surgery cancellation depends on whether the surgery is planned or emergency. Specifically, the planned surgery using regional anesthesia. If you see this, 3.7 planned surgery using regional anesthesia is 3.7 times higher odds of cancellation compared to the reference group. Okay, now this have you understood? Priyanka is writing. Is it possible to comment on an interaction when the dependent variable is ordinal? Let's see. Why not? In regression, all the options in, if I open your day 3 data, presentation, day 3, diabetic retinopathy. Without tummy. This was the ordinal logistic which we performed. So here the same. If I want to see the this thing between, let's say, hypertension, what do you want to see? Gender and diabetes mellitus duration? Or you can take gender and hypertension? Okay, no, you want to see between ordinal, you want to take it as a independent variable, or in case of dependent, you said like dependent variable. Okay. So dependent, in that case, I may go to the model builder. And again, the same thing. Add new block, gender, and let's say hypertension. So I'll press control, hypertension, add it here. Wait for some time. No, it has not come, or what? It is soon. Now it has come. So if you see, first see the p-value. Yes, So like the way we have seen, p-value is not significant. So you will write that there was no significance. If there was a significance, you have to interpret this 1.49. How will you say? So dependent variable, in this case, we always say that the odds of falling into the higher category. So how will I say that if the person, if the patient is male and having a history of hypertension, he was having 1.49 times higher odds of falling into the higher category. That's how you will interpret. The same thing. You will take the two category, this thing, and then you will express this. So you will say a person who is male and who is having a history of hypertension is having 1.49 times higher odds of falling into the higher category, because you remember now how do we club the cumulative category in case of odds. Similarly, in multinomial also you can do the same thing, because in multinomial it is basically you are having two different model, and there also you can see the interaction. So main effect is interaction, just see the reference level. The problem comes in interpretation when there are two levels and you don't know how to say. So just see the first of both and then see the reference. If one is dependent and if one is continuous and other is categorical, then also continuous you can say every unit increase additional, and this you say like if the person is falling into that category, right? That way you can interpret, Priyanka. In case of ordinal also the same concept, because
Ma'am,
interaction. Yeah.
ma'am, in case we have to see the other way around, like the male with no history of hypertension, then we have to go to that, change the reference category and again do the same, no?
Yes. Like I what you are doing, saying that you want to say male with no hypertension. So you go to this reference level and here you change hypertension is having no, then if you say write it yes. Yes, in Jamovi this is like so nice. Now you just click and everything, like the most of the functions. So now you can see it's 0.67. You said now male having no hypertension.
Yes, ma'am.
67. Means this will remain the same, but yeah, odds will keep on. Similarly, if you want to see in female, you change the reference level from here. Right?
Yes, ma'am.
Okay. So now coming to,
Ma'am, I have a question.
please, Dr. Arun.
Ma'am, so when we did a interaction checking in the ordinal logistic regression, and in the previous, ma'am, the odds obtained was 1.49. So, ma'am, I remember when we were discussing this in our last class, it was told that in ordinal logistic regression, the estimate obtained shows us the odds of falling into the between two categories, and that odd remains same in all the categories, ma'am.
Yes,
For
yes.
example, ma'am, like the odds in this particular slide in front of me shows 1.06 for age, ma'am. Ma'am, the first row, ma'am. The first row age predictor, and the odds is 1.06, ma'am. So the sanctity of this estimate is maintained, ma'am, all across this dependent severe, all across the ranges of the categories of the dependent variable. For example, no DR to mild, mild to moderate, moderate to severe. मैम जब हमने ये निकाला मैम, जब हमने इंट्रैक्शन चेक किया था इन द प्रीवियस वन जिसमें 1.49 आया था, तो उसका भी यही इंटरप्रिटेशन रहेगा मैम
Same.
कि अगर मतलब मैम ये तो दूसरा है मैम शायद, लेकिन जो पहला वाला मैं निकाला था
Okay, binary
कि
logistic.
नहीं मैम, नहीं नहीं मैम, मैम आपने इससे
तो
पहले वो रेफरेंस
ओके, जो एक मिनट
रेफरेंस चेंज की।
एक सेकंड रुको।
Hmm. यस
हाँ
मैम, यस मैम, ये वाला मैम। तो मैम इसमें मेल और जिनमें हाइपरटेंशन नहीं है उनमें 1.49 का ऑड्स आया था। तो ये इसकी सेक्रेटरी प्रिजर्व रहेगी मैम ऑल थ्रू द वेरियस स्टेजेस में मैम, जो डिपेंडेंट वेरिएबल की थी मैम।
yes,
ओके मैम।
that's the proportional odds. That's why
या
you
मैम,
get only one odds ratio.
यस मैम,
What
ठीक
is
है।
the
Dr. Sumana, do you want to say something? Okay. Anyone who have not understood wants any concepts to be repeated or something to be clarified? Please,
Could
you
you
can
please
type.
repeat this one before the binomial one?
Okay, so what should I repeat? I should repeat the
This
interaction of binomial or interaction of ordinal.
by interaction of binomial. Because
Okay.
that time my connectivity was poor, I could not able to
Okay.
hear.
Okay. So this was, I'll just cut this. So Dr. Sumana, like this was the initial. I just started with binomial logistic, and like you know that when you open the interface of binomial logistic, the dependent variable is the surgery status. Surgery status, it's been classified as cancelled or not cancelled. This is the box of covariate, and you can see the sign. This is the sign of scale variable. So I have entered the age here, and which is my scale variable. Here there is a BMI also, but can you recall why I am not taking BMI here? Because
Because the odds, the p-value was more than 0.2.
very right. When I did the univariable this thing regression, then it was okay, Haripriya. I'll repeat the interaction of ordinal also. So when this I'm right now repeating the interaction of binomial. So I have not taken here the chronic disease and BMI because they were the p-value was more than 0.2. So that's why I have not taken. And for simplicity, I have taken three variables here: admission type, anesthesia type, and surgery type. So I just, if I want to see whether there is an interaction between surgery type or anesthesia type, means if it is a routine surgery and if it is a general anesthesia, so is the odds of cancellation of these two more than the rest of the thing, or is there any interaction with it? Again depends on a research question. So if I wish to check the interaction, how will I do? So I'll go in this, I will open this is usually like this. So I'll open this model builder, which we opened in case of a hierarchical regression also. But again, we said that there is no need always to test for the hierarchical, since if you have already tested that p-value, you can enter all these variables together in one block. So all these variables are here in the another block. Now I need to add one new block. Why? Because I need to enter these terms, and so that's why I have kept this add new block. And then I will select these two, anesthesia type and surgery type. I will hold this and I'll drag this here to this new block. Sometimes it, like right now, you will see that it didn't go. Just a sec. So yes, now it is here. And then I'll wait for some time. Then you can see the result. So if you see the result, you can see here that how to interpret it. So ideally, if you see the p-value, it is not significant. It is, what is the p-value? It is 0.558. So what will I say? I will say that we did not find any interaction between the type of anesthesia and planned surgery, and that's it. I will just give this table and give the interpretation. But if this interaction is significant, and let's say it is significant, and the value of my odds ratio is 1.37, then how will I interpret? Then I will take the first of both, regional and planned. So I will say that the surgeries which are planned, and which are being done in the regional anesthesia is having a 1.37 higher odds of getting cancelled as compared to their reference level, which is the general anesthesia and emergency surgery. So that's the way we interpret the interaction. If it is significant. If it is not significant, then we just write one sentence that the interaction was not significant. That's it. You don't give this p-value and odds ratio. That's not needed.
But what is the extra advantage of doing this interaction? Or is it my questionnaire of the my questionnaire should have something so that I do it?
Actually, you should see in the literature or in your research question if something is there or not. Right now, you just have seen that in case of that linear regression, there was a decrease. With age, it was, I think, 1.06. Or when there was a, like we were doing with the linear regression, I'll just show the effect got modified. It depends on the question, research question. Where there? Okay, you guys are having that question, Dr. Shamshad is saying. Just a sec. No, I just want to show this one there, no? Yes. This we saw now, just now. I don't know whether your connectivity was preserved at that time or not. That if there is if there is an interaction, although p-value is not significant here, but if you see the estimate, there was a change of estimate. This is not significant. But yes, if this value is significant, you can see that the value of estimate, it gets modified in the presence of other variable. And that you see as a researcher also, and you can just see the inherent nature of variable also. It does, can that affect? And you can discuss those things. Is it okay, Dr. Sumana?
Say that if I, as I'm a study on burn, if I say, okay, what is the predictability of a gender with the outcome of burn, and another is the gender with the percentage of burn or something else, or gender with the age that I can do,
Yes,
in the interaction.
You can again, if you think again, you can see like a female might be working for more number of hours in the kitchen, or the place of burn and gender you can see. Whether
Yes,
the
ma'am,
person,
what I have seen still so far, the data that I have collected, the female patients are having more in number. So the female definitely, their preponderance is more. So female with the age, because maximum of them are from the middle age group.
okay.
So still now that so far data I have collected. So the female with the age I can do for interaction.
Yes, you can do. You can definitely do
If
that.
there is a surgical reason.
You can do that. But you have to explain.
Why?
Okay. Why I'm doing that?
Yes, in the discussion, you have to why you thought that maybe with increasing age it is less because the person is more mature. Maybe a girl who is doing who got burned who's 21 year, and the person who is 26 year or 27 year. Maybe with more experience, does that burn severity decreases or increases or what? So if you have got some theoretical background, because whatever finding comes, actually you have to discuss that also. Why you think so as a researcher? Then you will have to look for the reasons why it was so. And that's why main time you will see these days we do a lot of mixed method study also. Because if something of this sort you are finding it in your quantitative, then you might interview few of those ladies and you can virtually ask regarding the burn, because burn break. Okay. Because burn is you can do some qualitative studies also, seeing right now you are seeing the data, and for those reasons why that particular it is coming or less or more, for that you can introspect and you can go and interview few of those maybe relatives or maybe
as I am a microbiologist, the study was initially about the findings, the microorganism
Infections.
responsible,
Yeah.
infections responsible for bounce. Then I thought of putting this other information so that it become a better one. So that's why I
Okay.
have
Then it is okay. Then this is more than enough. You can just see the interaction between age and gender or any other variable.
and I can also see the interaction between the microorganism found with the age, because sometimes
Definitely. This might be a
Antibiotic
useful this
dose.
thing, because maybe there will be some predisposition for a particular organism, maybe some other comorbid condition. I don't know, microorganism with some other comorbid conditions, like maybe some already pre-existing this thing,
yeah,
genetic.
colitis or something else. What?
Yes, PID, presence of those. You can definitely see that.
Okay.
Excuse me, ma'am. Ma'am, I have one question.
Yes,
Ma'am,
Priya.
for the age, when we were considering age as a independent variable, then the estimate was 0.06, and the dietary habit, vegetarian, it was 4.79. But when we considered both the variables, interaction between both the variables like age and vegetarian dietary pattern, it was 0.04. Maybe age से भी it was मतलब very much decreased, and when we compare it with vegetarian, it is very much decreased. So can we मतलब can we interpret it in some way कि how मतलब estimate how much, why it was so much decreased when we compare it with the vegetarian diet?
Yes, you have to actually say these things, like I got your point. This 4.79, actually, when there was no interaction, there was a difference between BMI is 4.79.
Yes,
And
ma'am.
when you have considered age, then it was 0.04. It has decreased so much.
So much, yes, ma'am.
Yes, so you will have to see, like you and here, but it is not the same this thing. Here you are keeping the age constant, but here it is with increasing age. So interpretation is different. Means every 1 year increase, if the person is a vegetarian, only 0.04. So like you can take those many years and then you can see, because here the findings, it is after keeping this constant. The age here, you are not considering the effect of age. You are just seeing the veg and non-veg, but here you are considering the effect of age also. So maybe you can write exact reason in the same research. It is not possible for you to conclude everything, but at least you can come up with your finding, whatever your data is saying, right?
Yes, ma'am. Okay, ma'am. Okay.
Because right now, if something, although this is a hypothetical example and hypothetical data, but if actually this comes, I'll have to look into the factors probably, and that's why you will see that maybe we always write another study should be planned to see, or this was one thing which we could not clarify. That was a limitation of our study, although there was an interaction, but we could not justify why this was happening or something like that. You can write that, and maybe someone will read, he will find this gap, and then he will study this factor. That's how one research keeps propagating, or you try to improve on the previous research.
Okay, ma'am. Okay, thank you.
And I think Dr. Haripriya wants an interaction between the ordinal. So ordinal again, if I go this ordinal, it is again the same. I will just cut this. We have performed this ordinal. This is again the same interface as we see in the binomial logistic. In the dependent, you move this diabetic retinopathy severity. In covariate, you move the continuous variable, which is age, and gender, diabetes, duration, hemoglobin, and hypertension. If I want to see the effect, whether it is getting modified, effect of gender on the this retinopathy severity, if it is getting modified by the presence of hypertension or not, because we have seen that in the original article that gender was a very major predisposition. In females it was more, okay, no, that was in frailty, not here. But again, if you see if it is not at the simple without interaction, then male is having a higher odds, which was significant. So if you see right now, the male is having a higher odds, which is 2.15. And if you see the hypertensive, again, hypertensive is having 2.43 times. Now, if I want to see the is there any interaction, are more male diagnosed with the, because the if you see the prevalence of hypertension, is it same in male or female, or is it different? So suppose, let's say the prevalence of hypertension is more in male. So definitely this hypertension might be a confounder. That's why it is like more male are having this odds ratio. So you can check this by moving these two. So what I did, I have selected this gender, press the control button, and then press the hypertension, and then shift. I have added a one new block. Okay. Yes, if you do in the same thing, it will come in the same model. If you do in the other this thing, then it will come as a separate model. And you can just compare the AIC and BIC. So if you see this, so now if you see the interaction, this thing. So initially it was odds ratio was, now it is modified also. This interaction is not significant actually here. It is 1.49, but it is not significant. So you can say that this thing is more like odds of falling into the higher category. A male who is a hypertensive is having a 1.49 times odds, higher odds of falling into the higher category of the diabetic retinopathy. That's how you interpret. Is it okay?
Okay, ma'am.
So if it is okay, I think we can go, but I have not told you the test of parallel lines. I will first tell you that, then you go to the breakout room, check all these interactions. We have shared the data set with you people. And let me, Priyanka, ma'am, to address the confounder, we do adjusted odds when we can take all the predictors in hierarchical form. Is it the interaction term different where we take only two predictors? In interaction terms, yes, basically it is only the, I have not told you many, you can take three also. Here you can see like there are many ways, but it will be like interpretation will be very complicated. Yes, you are right that to address for the confounder, but there are various types, like there is a moderating variable, there is a modifier, effect modifier. And many times you want to see like whether even after like controlling, adjusting for confounders, is there any other variable also which is affecting, like two variables are getting affected by each other or not. So in that case, you can take the interaction. There are various ways, two-way, three-way, but that makes your model very complicated. So that's just one way which we have told. It's not always necessary to take these interactions. Shall we change the odds and interpretation without interaction as well as in our result? Of course, the odds will get changed, because if you see the model, initially the odds was different. If you see the model 1, so here the odds is 2.15 in male and female, and in hypertension it is 2.43. But when you have put the interaction, the odds was changed. In gender, it was 1.66, and here also in hypertension, it is 1.96. So if you are giving your result, if it is significant, then you have to give them different odds, or you can write like indeed both the discussion. So final interpretation will be, it depends what you want to show. If you want to show your interaction, you will give this table. If you don't want to show, you will give the other table. Or if you just want to say that it is you are suggesting model 1. So you will go for that. It depends. As a researcher, final interpretation will be your call. Interaction, you can give both. Yes, we have seen, but depends. You can show both the model, you can show both the table, you can describe that. Is it okay, Dr. SV? Biological plausibility. Yeah, true. That's the very important criteria to go for interaction. Now I'll show you the concept of proportional odds in the GLM for which we have downloaded. So this is the so if you click this GLM, I've shown you that there is a okay, this was not, let me open that data. I'm closing all these files. So I'm again coming to the ordinal logistic regression. And there, if you can recall, on Saturday, we performed 4 binomial logistic, taking dummy variable 1, 2, 3, 4 with the reference one for testing the test of parallel lines. And we said that variables, independent predictors who are not fulfilling the assumption of test of parallel lines, you cannot take those variables in the final model. You have to drop that particular variable. So here, how to go for that option? So go to this linear model and click the option of generalized linear model. So if you click the option of generalized linear model, okay, linear model, generalized linear model, here I'll click the option of proportional odds. The dependent variable was diabetes, this diabetic retinopathy severity. And then gender, I have to put it in covariate, age, as a factor, gender as a factor, age here in covariate, diabetes duration, HB1AC and hypertension in this nominal factor. And then I will come down and then in the option, I'm not going with the other options of GLM. Why? Because the interface is little complicated, but you can see there is an option of parallel line test. So you can click this option of parallel line tests. And you can see the p-value. So right now, please focus on this column. So in this case, parallel line test says that if the p-value is more than 0.05, then only your test of parallel line assumption gets satisfied. More than 0.05. So here all the variables, if you see age, gender, diabetes duration, hemoglobin A1C, and hypertension and this interaction is also coming. I'll move this interaction back otherwise. So all these are more than 0.05. So here we don't want our p-value to be more than 0.05. So when I move that interaction term inside back to its window, then you can see the gender is now, it is not satisfying the assumption of parallel line. Why? Because it is showing you, you can see here that the p-value is less than 0.05. And if the p-value is less than 0.05, that means it is not satisfying the test of this assumption of proportional odds. So we will not take this gender in our final model, and we'll only take these 4 variables, which is the age, diabetes duration, HB1AC, and hypertension. Okay, is it okay? And you will write in your interpretation that the parallel line test, the gender could not satisfy the assumption of proportional odds. Therefore, we did not take that, and we have proceeded with these 4 variables for all model construction or for prediction. So this option, how do we see? Go to generalized linear model, and in the generalized linear model, if you open this, there's an option of all like logistic. I have shown you this in the beginning, and you can go for your test of parallel line, which is there in the option of this option. Last one. Here is the test of parallel line. Is it okay to everyone? If yes, then Dr. Supriya, to open the breakout room, and all of
Yes.
you, we have shared the data set with you. You can practice and you can try to say interpretation many times. Then it will be easy for you. How to, and like you can see. And those of you who have downloaded, first is to download this. If you want to check for this test of parallel line, please download first the current version.